So hey guys, welcome back to the channel, and today we'll be doing something called facial recognition or facial detection using opencv, which is computer vision. So you see all these faces in the image. We'll be plotting a square or a triangle around their faces, and this can be done easily by just calling the cascades classifiers and then just running them through the image. Uh, so let's just dive into it. Yep. So first of all, we import the module, import cv2, and we'll open the cascade in face underscore cas variable, which is equal to cv2 dot. Cascade classifier. We will use this to open the cascade, and the path. So these cascades, we can find it online. So what they are predefined classifiers saved in XML format. So we'll just copy the path, and we'll be using the hair cascade frontal face default, and you see there are the bodies like Russian, smile, upper body, wall clock, and there are a lot of them. So you can just find it online. I just dropped the link for this in the description. And so we just go type the cascades, type the path to it dot xml. This is very important, otherwise it doesn't work. So we want it to be dot xml, and we'll open the image using the imread function of opencv2 module. So imread, and it's pic3 dot jpg, which you can see here. pic3.jpg. We have to be very sure about the name and the whatever comes the format like jpg, png, or whatever. We have to be very careful about it, otherwise it'll just give unnecessary errors and you won't be able to understand why is it coming. So now we'll be converting it down to grayscale. So why we doing this? You see here, grayscale has only it's just a 2D array, but you see image, it's a 3D array. 3D because it has three components, RGB, but gray has only one component, which is white, which goes from 0 to 255. So we'll be converting that to reduce the size of the image, so that the cascade runs through faster and it's more effective. So for that, using this, so source is img, and we'll be using something called cv2 dot color. So we want to convert it from bgr to gray. So just to gray, yeah, to gray, not t, just the number 2. And the coordinates of the faces will be predicted or found out by running the cascade through the image using a function called detect multiscale. Why multiscale? Because you see we have multiple faces, that's why. So face underscore cas dot detect multiscale, and the source for this is gray, and the scaling factor is basically reducing the size of the image. So if you imagine, if you are having an image of size like it's 1080p, it's a lot of pixels and some of them are unnecessary, so we can just estimate it down to 480p or 360p. Scaling factor works in somewhat a similar way. It's basically called pyramiding down. And what is min neighbors is, it just tells like the quality of the faces we predicted, like how much accurate it is. So the lesser it's the better, but we have to like vary this to find out. It depends on image to image, or you can say if you're doing it like live, like if you're streaming streaming a video and you are going through the pixels, that camera will have a static amount of resolution, so we won't have to change it again and again. But going through images we might have to, so that's why. So now we have a list. Faces is a list which has subtuples with 4 parameters: x, y, the width, and the height. So we'll be calling them x, comma y, comma width, comma height, and we'll be running a loop through them. So we should have five tuples in that list. So because we have 5 faces, and now we'll be plotting the rectangles around their faces. So we use the cv2 function called rectangle. So the path is image. Yep, right now point 1, where is the starting point of the rectangle, is x comma y, which should be in a tuple. Point 2, where it's ending, is x comma y, but x will have plus w and h will have plus y. Why? Because you see this point, imagine it to be x 0 comma 0, x comma y, and this is the width and this is the height. So this part diagonal will be x plus w and y plus h. So that's why we are doing it in the same manner. That was just an example for you to easily understand. So x comma w comma y plus h, and the color we'll keep it at blue. So 255 means completely blue, 0 green, 0 red, and the thickness of the line should be 2 pixels. That's all, and we are done. Basically we just show the image using imshow function of cv2 module. So imshow, we wanted it to be in a window called result, and we want to show image, and cv2 dot wait key. This is very important, otherwise your window will keep crashing and stuff like that. So you keep it as 0. We can add, like, if you press key, if you press a key, the window will close. Like if you press q, it will quit, like that. But we are not doing that. That's for another day. Okay, so yeah, I forgot an underscore. Yeah, so you see we perfectly have like squares around their faces, but we just vary the scaling factor and the min neighbors, and let's see the effect of it. So if we scale it down even more, suppose it doesn't make any difference, but if you do it like 2, you see the image is getting so blurred that these faces are not even considered. So we'll have to scale it down lesser, like 1.5. It doesn't work. 1.1 doesn't work. So 1.9 works with 4 people, and so on. So we'll keep it at 1. It's too much, so we'll keep it at 1.4, and it's perfect now. And min neighbors does this, it just changes the quality, and we can do the same for anything. Literally, we can stream a video and we can call its individual frames and pass the same. We can just make this as a function, this entire part as a function, and instead of pic3 we'll be sending the frames from the video, and then we'll be doing the same and just showing it. We'll do that in the next video. Thank you for watching, and I'll see you in the next thing. Sure, bye.